Math 12A. I've gone over the homework for the first part of section 8.3, so we have to do the last part of section 8.3. I did examples 1 and 2, so there's examples 3 and 4. Good news, bad news. Good news, I'm going to skip example 3. It's a word problem. I'm making an executive decision and saying we're not doing it. But I am doing example 4. It is important. All right, example 4 is, you really got to pay attention to it, okay? Example 4 has many parts to it. So I'm going to need some colors for this one. Yes, I know, that's bad, but I'm going to need some colors for it. So this one, instead of talking about a point and a line, is actually going to talk about 2 different lines. So in example number 4, they say the equations of 2 lines are y is equal to 2x plus 3, and I'll do it in purple, y is equal to 2x minus 4. Now, one of the things I want you to notice about these 2 lines is that the slopes are the same for both of them. The y-intercepts are different. What that means is I have 2 parallel lines. So before I read any further, before I even look at what they want, I'm going to draw those 2 lines. So y is equal to 2x plus 3 means my y-intercept is at 3, 1, 2, 3, and my slope is 2 over 1, so up 2 over 1. So here's that line. The purple line is y is equal to 2x minus 4. So this time the y-intercept is at negative 4, 1, 2, 3, 4. The slope is still up 2 and over 1. So it creates these 2 parallel lines. So I have them color coded to try and keep all of this straight. So this is purple, y is 2x minus 4, and this is black, y is 2x plus 3. So they're actually going to ask me for 3 different things. 2 of them are actually pretty simple. So they're going to ask me find the vertical distance between the 2 of them. So this is the first thing they ask for, find the vertical distance between the 2 of them. So what do they mean by vertical distance? What they mean is if I drew a straight vertical line from one of these lines to the other one. So it doesn't matter where you draw it, as long as it's a straight vertical line, how far would I be going? Now, it doesn't matter where you draw that vertical line, technically, but there is an easy one to do it on. If you want a straight vertical line, the y-axis just happens to be a straight vertical line. And by the way, I know where the black graph touches the y-axis because I know that the y-intercept is at 0 and 3, so it's at a height of 3. I know that the purple line has its y-intercept at 0 and negative 4. So if I'm going to draw a vertical line from 3 down to negative 4, how many squares is that? So for vertical distance, I'm going to do 3 minus negative 4, which is going to give me 7. If I drew it on graph paper, I would just have to count squares. Some of you can just do that in your head, right? You can do 3 take away 4 is negative 7. You know that to go from 3 to negative 4, that's a distance of 7. So that's it for vertical distance. It doesn't get any harder than that for vertical distance. That one's great. Love that one. All right. They also want to know the horizontal distance. So horizontal distance is just if I draw a horizontal line straight across from one line to the other line, how far would that be? Again, there's an easier choice. It doesn't matter where you draw that horizontal line, except that it's not right or wrong, but it's easy versus hard. If I take the x-intercept here and draw a straight horizontal line along the x-axis, and here, the only problem is I don't have the x-intercepts. I don't know what those are, but I can figure them out quite easily because an x-intercept means that the y value is 0 because I haven't gone up or down, I've just gone back a certain amount. Same thing over here. The y value is 0, so I haven't gone very far. So if my y value is 0 and the equation is y is equal to 2x plus 3, then if my y is 0, that's 2x plus 3. If I solve, negative 3 is equal to 2x, so x is negative 3 over 2. So this is at negative 1.5, negative 3 over 2, negative 1.5, negative 1.5, I don't care what you call it. Here, same thing for the purple one. If I put 0 in as my y value, and I have 2x minus 4, then 4 is equal to 2x, and so x is equal to 2. So horizontally, I'm going from negative 1.5 to 2. So same as up here, I'm going to do 2 minus negative 1.5, which is going to be a distance of 3.5 squares. And again, some of you could just do that in your head. You know that to go from 2 to negative 1.5, that's a distance of 3.5 squares. Again, if you drew it carefully on graph paper, then you could just count the squares. All right, the last one. The last one, trying to find a good color. Just hold on, trying to find a good color. One that will show up nicely. Will this dark green show up nicely? Not too bad. Okay. So the last thing asks for the shortest distance. Now, when we had in the last questions, we had a specific point and a line. I said that the shortest distance from that point to the line was a perpendicular line. So from the point, we drew a perpendicular line to the line. We're going to do the same thing here, but you have some choices to make. And it's not a right or wrong choice, it's just a choice, okay? So what you're going to do is you're going to choose one of the, usually I say, you're going to choose one of the y-intercepts, either 0 and 3 or 0 and negative 4. Doesn't actually matter. In the textbook, they choose, I'm just looking, they choose, I can't even tell at a quick glance. Oh, no, they choose to use this point. So they say if from this point I draw a perpendicular line to here, how long is that line? Now remember, the shortest distance is always a perpendicular line. So I figured out with the blue, with the vertical distance, that the vertical distance was, can't even remember now, whatever it was, that the vertical distance was 7, right? The vertical distance in blue was 7. The horizontal distance was 3.5, which means the green answer should be less than 3.5 because it's going to be the shortest distance. Once I pick a point that I'm starting from 0 to 3, and I'm drawing to the purple line. That's important, that I'm drawing to the purple line. That means that is the equation I'm going to use, and I'm actually going to forget that this is a line at all, and I'm going to treat it as if all I know about this is this point, 0 and 3. So I'm not going to end up using this equation because all I'm using about that whole line is just this one point, 0 and 3. And now it becomes a question like what I did in the other ones where I have a point, 0 and 3, and I'm drawing the line to this purple line, to the 2x minus 4. So just like before, I need to figure out where is it touching the purple line. And to do that, I have to come up with an equation for the green line. So y minus y1 is equal to slope times x minus x1. So the beginning of this green line is here at 0 and 3. So that is my x1 and my y1. So I'm going to do y minus 3, and I'm going to do x minus 0. Now in terms of slope, it is perpendicular to the purple line. So the purple line slope was 2 over 1. So the green line slope is going to be negative 1 over 2. Opposite sign, flip the fraction over. So I have y minus 3 is equal to negative 1/2 x. So I have y is equal to negative 1/2 x plus 3. I also have this equation, the purple line equation, y is equal to 2x minus 4. I had another equation up there. I had that black one, which was y is 2x plus 3. I'm not using it because the line is ending at the purple graph. The green line is ending at the purple line. So the purple line is the equation I'm using. I'm not using the black one, okay? So the negative 1/2 x plus 3 has to be equal to the 2x minus 4. So if I move this over here and subtract it, I have negative 2.5, which would be negative 5 over 2x. If I move this over here, negative 4 take away 3 is negative 7. So my x is going to end up being something really gross. It's going to end up, where is Harriet? Hold on, there she is. It's going to end up being negative 7 divided by negative 5 over 2. It's going to end up being 14 over 5. Ew. So my x ends up being 14 over 5, so my y, I can put it back into here or back into here, doesn't matter. If I put 14 over 5 times 2 minus 4, I get 8 over 5. So I'm running out of space to label stuff. So let me take that out of there. Let me take that out of there. So this end of the line is 14 over 5. And if you prefer decimals, put it in decimals. And 8 over 5. So that is my x2 and my y2. So now I'm going to do the length of my line formula. They did it in decimals in the textbook. I have a tendency to default to fractions. I just like them better. I know that's weird. So my length is the square root of x2 minus x1. So 14 over 5 minus 0 squared plus y2 minus y1 squared. So 8 over 5 minus 3 squared. And then don't forget to take the square root of it. A lot of people forget to take the square root of it. And they said they wanted us to round to the nearest tenth. So it turns out to be 3.1. Now, remember I said it had to be less than 3.5 because the vertical distance was 7, the horizontal distance was 3.5, The perpendicular line is always the shortest one, so it has to be less than that. So you're finding three things. You're finding the vertical distance, the horizontal distance, and then you're finding the shortest distance. Again, pick one of the y-intercepts. When you do that, if I pick the black y-intercept, then I'm going to be using the purple line to draw to. So that is I'm going to use that equation. If I had chosen to use 0 and -4 and I had drawn my line to the black graph, then I would have ignored this equation and used the black graph equation. It's up to you. You can do it either way. You should get the same answer. So I'm only going to give you 2 questions to try, just 2, because there's quite a bit to it. So you're only going to be doing 2 questions. That's it. And then we only have one more section to go. I hope most, if not all of you, saw my note on Google Hangouts. There is a person who on Monday has to do a presentation at 11 o'clock. So their concern is if they don't have the test done by exactly at 11, they're feeling kind of restricted by that time, which I totally get. The suggestion is, can we move it to Tuesday? I don't have a problem with that. My only thing was, if there's one person in that class, are there more people in that class who might have a presentation on Tuesday and would then be in the same situation? So Alice and Yadam were the other 2 people that were in that class. So if you just, are you available to do it on Tuesday? If you have to do a presentation on Tuesday, it might make the time difficult. So just let me know if Tuesday is okay. Most of you have said Tuesday is fine, but just let me know if Tuesday is okay. Especially Yadam and Alice, because those are the ones I'm concerned may have a presentation to do on that same day. And I don't want you to have to worry about time restrictions at all. I don't want that to be a concern, okay? So other than that, just 2 questions for tomorrow. And yeah, that's it. So have a good day.